So I want to find all the solutions on the interval from 0 to 2 pi of this equation, and I need to give exact answers. It looks like we're all in terms of the sine, the same trig function. I actually don't like the fractions there, so I'm going to multiply everything by 4 so that I can clear the equation of fractions. I have to do it to both sides, but now I don't have fractions to worry about. The next thing I'm going to do is get all the terms on one side to see if I can factor it. So I have 4 sine cubed x plus 4 sine squared x. Moving this term over, I subtract it, so it's minus 3 sine x, and same with this one, minus 3, and that leaves us 0 on the right hand side. Now there are 4 terms here, and that clue of seeing 4 terms is to try factor by grouping. So we're going to look at the first 2 terms here and factor out what's in common. There's a 4 and there's 2 sines multiplied together, so a sine squared x. That will leave me a sine x for the first term, and I factored the whole thing out there, so that's just a plus 1. Now looking at the other 2 terms, the only thing in common is a negative 3. I'm going to factor that out in front. That leaves a sine x, and then factor the negative out, so make it a positive 1 equals 0. Now, factor by grouping will work if this parentheses stuff that you have left matches, and it does. So I'm going to factor that out in front. So I'm going to factor out a sine x plus 1 in parentheses. What that would leave is 4 sine squared x on the first piece, and it would leave minus 3 on the second piece equals 0. So now I have it factored. I'm going to use the zero factor property. So I'm going to set this factor equal to 0 and solve it. Sine x plus 1 equals 0. And I'm going to set the second factor, 4 sine squared x minus 3 equal to 0. Now solving the first one, sine x, subtracting 1 from both sides equals negative 1. So I'm going to find solutions. X equal where between 0 and 2 pi is the sine negative 1, and that's down there at 3 pi halves, right? If we think of the unit circle, it's right down here. And so I'll only get one solution from that. Now I'm going to come over to the second equation. I'm going to add 3 to both sides, and then I'm going to divide by that 4. So I'm going to have sine squared x equals 3 over 4. And then the last thing I'm going to do is get rid of the squared by square rooting both sides, but I need to put a plus minus on there when I do that. The squared and square root will cancel. So what I have left is sine of x equal plus or minus. The radical applies to the numerator and the denominator, so we can split it up when there's one fraction underneath. So putting it on the numerator at square root of 3, applying it to the denominator at square root of 4, which is 2. So now I can recognize that. It said exact answers, and those are unit circle values. I need to just give all of the angles whose sine is either square root 3 over 2 or negative square root 3 over 2 because of that plus minus. So thinking of the unit circle, the square root 3 over 2 is the bigger value, so it's going to be right here where this is 1/2 and square root 3 over 2, and then it's going to be also here, here, and here, because in quadrant 2 it's negative 1/2, but still square root 3 over 2 for the y. Down here in quadrant 3, it's negative 1/2 and negative square root 3 over 2, but we do have the negative on here. And same with quadrant 4, the sine value there is negative square root 3 over 2. So it looks like I'm going to get pi thirds, 2 pi thirds, 4 pi thirds, and 5 pi thirds. So there are all of my solutions.